Okay, one more example from the section. This one just asking us to compute a limit, the limit of this rational function as x approaches infinity. Now, the idea with these are hard limits to do exactly because you can't really substitute infinity in for x. But what it's asking is pretty straightforward. What does this function approach when x gets, in this case, very large and positive? So if we put a very, very large number in for x, or as we do that, what is this expression approaching? Okay. Well, the easy way to think about this is it's kind of like asking you, does this function have a horizontal asymptote? Okay. Because if a function has a horizontal asymptote, it must flatten out to that value of y as x gets large, either positive or negative. Now, if you look back a few pages in the book, they do have a table to figure out when and where rational functions have horizontal asymptotes. Okay, now this one actually fits into one of those cases. They say whenever the degree of the numerator is smaller than the degree of the denominator, I think it's the first case they have in that table, there's a horizontal asymptote on the line y equals 0. Okay, so this is, the numerator is 3x to the first power. The denominator is 4x squared minus 1. So what I do is I see here, looking at this rational function, is that the degree of the numerator is less than the degree of the denominator. Okay, when that happens, this function, the result in that table is that it must have a horizontal asymptote at the line y equals 0. Now when the degree is the same, that's when we have to divide the leading coefficients. So if this had been 3x squared, then I would have a horizontal asymptote at y equals 3/4. Okay? But if the degree in the numerator is smaller, the horizontal asymptote is at y equals 0, which means that this function has to approach 0 as x moves very far to the right. Right? It has to flatten out on this horizontal line, and x moves to the right. So without, if we wanted to, we could construct a table, a table of values and put large numbers in for x, but we don't have to do that. We know from the theory on horizontal asymptotes that if this function has a horizontal asymptote at y equals 0, then this limit must be 0. The function must be approaching 0 to get close to this line, y equals 0. Okay, so that's the limit.